opportunity. But anybody in the beekeeping thing, in my perspective, everybody here seems like they're willing to destroy their hive. So I don't understand what the problem is, you know, why it becomes such a.
Yeah, I appreciate that. I know there's a couple other comments. We're almost out of time. Our next scheduled presenter is almost up.
The election is published.
Election's up. Okay. So
Your email.
I agree, I think, with everything that's been said. There are concerns or considerations. Personally, I like the idea of the may language, which gives the state inspector flexibility, but still says destruction is allowed and supported by the law. Writing laws to keep up with every development of science along the way is impossible. Like it's been talked about. It's so difficult to get them on, to get them right, and then to remove them when they're wrong. We try to write one that gives us reasonable flexibility within the developments that are on the horizon. But please tell us your feelings in the survey there. Our next presenter is Dr. Erika Plettner from Simon Fraser University in British Columbia, Canada. For those who remember, Danielle Downing was our state bee inspector before Joey, if I remember right. She's gone on to other bee research and things, but she actually studied at Simon Fraser University. So there's our connection, our Utah connection to this institution. Dr. Plettner, I can't tell you precisely because I don't remember, but there was a news article a couple of months ago that came out talking about how they had pursued some research and kind of incidentally discovered that what they were studying inhibited or affected Varroa mites. So I'm sure she'll give us an update on that. I just thought it was relevant and interesting as kind of even more of the cutting edge of study than the vaccines and things that we've been talking about. So as soon as she's on, we'll put that up there. Should be within the next couple of minutes. It'll be Dr. Erika Plettner from Simon Fraser University. She's on.
Hi, everybody. Can you hear me?
Yes, we can.
Great. Thank you. Well, thank you for the nice introduction. Yes, I did my postdoctoral studies at the University of Utah. So that's my connection. So today, I'd like to tell you a little bit about our progress towards a new treatment against Varroa destructor. And this is a collaborative effort between my lab, where the new compound was discovered, and Stephen Pernal, who is the director of the Agriculture Agri-Food Canada Bee Research Station in Alberta, in Beaver Lodge, and various other colleagues whose work you will see in this presentation. So as we all know, Varroa destructor is a deadly parasite of bees, and it causes a lot of problems in our countries. A significant percentage of losses during overwintering are experienced due to the mite, or attributed mainly to the mite and the diseases it vectors. And for agriculture, and this is just my own guesstimate, so don't quote me on this, but for agriculture, this it has some profound consequences economically in terms of colony replacement, in terms of cost of lost business, and lower pollination of crops that depend on bee pollination. And I'm going to skip this because I think it's important to think about the life cycle of the Varroa mite. As you all know, they start out as sporadic mites riding around on adult worker bees in the colony, and they then find a cell with a L5 stage bee larva where they begin their reproductive cycle. And these are the female foundress mites, which then have multiple offspring while they feed on the pupa. And they emerge, the adult females then emerge with the bee when she comes out of the cell. And so as a consequence of this life cycle, we have here a number of individuals and the season. During the spring, of course, we have low levels of bees, and that also and low levels of broods. So we have low levels of mites, but these quickly explode during the spring and the summertime. And our mite populations really peak in the early autumn when we are increasing the sizes of our colonies so they can successfully overwinter. And so we have 2 treatment windows as a consequence of this. And that's the one in the spring before we harvest honey, and the one in the fall in preparation for winter. And as we all know, there are multiple options for treatment. Not all of them may be used in Utah, I don't know. But here in Canada, we have thymol formulations that we can use. We have hop formulations. These are natural products. There are also synthetic products, fluvalinate and coumaphos, but these are losing effectiveness due to resistance. And there's a bunch of literature that explains how this resistance arises. So let me know through your contact if you're interested in some of that. Of course, many of us use Apivar, which contains amitraz, the structure of which is shown here, and or these organic acids. So in Canada, Apivar and the organic acids are the most used, followed by thymol. One problem with the organic acids is that they are quite corrosive. These are very strong acids. And there's also some temperature restrictions in their use. So problems that we have are development of resistance of the mites. And unfortunately, though amitraz is easy to, so the Apivar is easy to use and is very popular, there are indications that it may be losing effectiveness because some resistance is beginning to show itself. The organic acids, as I mentioned, are very corrosive, and some of the treatments like thymol and formic acid also have temperature restrictions. If it's too hot or too cold, you can't use them. And so the question arises, what do we need for successful integrated pest management of raw mites? Well, I think we need new acariciidal treatments so that we can rotate and we can preempt or even significantly delay the onset of resistance. We need to integrate rapid mite monitoring with treatments. So treat only when economic thresholds are exceeded, and then use the full dose and make sure the treatment is effective. And holistic management, we should also continue thinking, we all do, but we should continue thinking about good nutrition, a clean environment, breeding of resistant bees, and the planting of more flowering plants. So now let's move on to the discovery of our new acaricide. This really comes from previous work where my lab was looking for feeding deterrents against moth larvae. And we found a particular compound coded 3C36 here that was very active. And so a few years ago, I asked the question, well, if it works against moth larvae, then shouldn't we test it against Varroa just to see what happens? And so we did what is known as the structure-activity relationship in a laboratory assay where we put 2 freshly freeze-killed bees with 5 Varroa mites in one dish. And we put the compound on a piece of parafilm. This is just like a wax paper type material that is stuck to the lid of the dish. And so here we have the number of mites that are paralyzed, the total of paralyzed and dead mites versus the compound. And we can see right away that our previous hit compound from the moth studies is also very active in this assay. And we also see a few other compounds of related structure. So for example, our main compound has a so-called propyl group with 3 carbons here and an allyl group also with 3 carbons here, but a double bond. If we put both allyl groups or both propyl groups, that's these 2 compounds here, they're already slightly less active, especially at the shorter time period of 3 hours of incubation. And if we change the arrangement, so here we have the two groups opposite each other, this is called para. If we put them next to each other on this ring, or one skipping only one carbon, this is called meta, there's these two, then we can see that they're significantly less active. So we clearly have a structure and activity relationship. In this assay, we also use thymol, the structure of which is shown here, as a positive control and as a comparison. So you can see that our compound of interest is as active as thymol in this assay. And in this assay, we also checked something else. We monitored where at the time of assessment, the mites were located. Were they located on the abdomen of the bee we provided as food? Were they located elsewhere, or were they on the glass? And so here's the structure activity relationship again. And on the blue, we see the number of mites that are on the glass, the ones on the abdomen and not on the abdomen. And we can see in the control, we see what the normal distribution would be like. We can see right away that with our hit compound, thymol, and a few of the other compounds I pointed out earlier, that most of the mites ended up on glass, which tells us that the compound is not only paralyzing and killing them, but also confusing them a little bit, because normally the mites like to go for the abdomen of a bee, even if that bee is freeze killed, because that's where the fat body is and that's where they like to feed. We also checked the physical properties of the compound. And so just briefly, we do an assay of how well the compound evaporates from this wax paper-like material that we use in our assay. I should point out that in our assay, the mites very seldomly come in direct contact with the compound. They have to climb into the lid to do that, and that's very rare. So the activity of our compound is due to a fumigant effect. It evaporates and then it hits the mites. And so we can see that thymol and our compound evaporate quite well. Thymol evaporates very, very well. So here we have the number of dead post-paralyzed mites. This is the previous structure-activity relationship. And here the compound in air. So we see that thymol evaporates quite well. Lots of compound in the air of this assay. And our compound of interest is up here. It does evaporate, but much less than thymol. Yet it has the same activity, and we reckon that that's useful in the field.
Does that mean that it might not be as temperature sensitive as
Correct.
formic acid?
Yeah, correct. Yes. So then we decided to field test the compound in 2019. And we tested in parallel at the Agriculture Agri-Food Canada station and in the Fraser Valley of British Columbia. Same experimental design was used, and we treated during 28 days with our compound. And for another 28 days, those 28 days, the dead mites were counted at regular intervals on sticky boards. And the dose we used was 5 grams of our compound, which is what that looks like. And these 5 grams were distributed using a solvent onto 10 sticks like this. And we monitored using sticky sheets placed underneath the hives. And so here we have the number of mites on the sticky boards versus the treatment time. And so we can see right away that in our treatment, right off the bat, we got a much higher mite drop than in the controls, which only received a sham treatment, so only the solvent here. And we see also that as time progressed, we started getting into our mite bloom, the natural mite population explosion that happens in the fall. This was a fall experiment. And in the treatment, we see that there was a suppression of that. This experiment was continued then. So this is day 28. These are the data I showed you in the previous slide. We then follow up with an amitraz treatment. And we can see that there's a significant mite drop in the control now. And that's because the mite population exploded. And so we're bringing all of those down with the amitraz. And it looks like we suppressed the population explosion with our compound. It's important to note that at the beginning of the experiment, we established mite populations by wash, by alcohol wash. And we had the same number of phoretic mites per 100 bees in the control and in the treatment. So there was no difference there. Yet, when we looked at wash 2, which was done on day 28, when we switched out our treatment and put in amitraz, we had significantly fewer mites per 100 bees in the treatment than in the control. And in wash 3, which is at the end of the amitraz treatment period, we did not see a statistically significant difference anymore, but mite levels were quite low. In terms of the number of infested brood cells, these we measured on day 28. So that was a busy day of experimentation. We counted the number of cells with pupae, with purple-eyed pupae, preferably, that were infested with mites on that last day of the experimental treatment. And we see very clearly, and we're very happy about that, that the number of infested cells in the treatment was much lower, and significantly so, than in the control. And there was no effect on the amount of brood, open or capped. There was no effect on the amount of stored food, honey or pollen. And a similar pattern was obtained in Alberta. And according to our chemical analysis of the release devices, which we retrieved and analyzed, 3.8 grams of the 5 grams we had applied were removed from the devices during this treatment. So we then, in 2020, we couldn't do an assay, field assay, but in 2021 we did. And because it was 3.8 grams that had been removed from the devices in 2019, we decided to try 4 grams of compound. And instead of using 10 tongue depressor sticks, which was a lot of work to install, we decided to use just a wooden wafer that gets put on top of the frames. And this is important. We also had to wait until our mite numbers were high enough. We started out with very low numbers. And so we had a late start on August 30th, 2021. And so here we see data, the number of mites on the bottom board, and the day of the experimental treatment. And we actually did a pre-experimental check this time. And then we started the experiment. And we also used a positive control. Thymovar is a commercial thymol product available and registered here in Canada for use in hives. So we use that as a positive control. And so we see that with the 4 gram treatment, we didn't get as spectacular an activity as we did in 2019 with our compound, which is shown in red here. And this is the control, and this is the thymol. And when we look at the whole experiment, so up to day 28, we had experimental treatment, then we used amitraz to follow up. We see that only in the thymol was there really a little bit of a suppression of the mite population explosion. In our treatment and control, there hadn't been. And so we started out with equal mite levels, 1. And the washes subsequent on day 28 and on day 58 were not significantly different. And we couldn't do mites in brood analysis because we ended up being too late and it was too cold. The queens had already shut down. So that was a little bit disappointing for us. And in the first 21 days, the average mite fall for our compound was in between that of the control and that of thymol. So that gave us a little bit of hope. A similar pattern was obtained in Alberta. And so there were some take-home messages we learned the hard way. First of all, we do need a higher dose. 4 grams is too low. And we do need to place the treatment between the combs, not on top. And we need to treat a little bit earlier. So in 2022, we decided to do another field trial of the compound. We used the same experimental design in both provinces. And we decided to treat different delivery methods, given that the delivery method was a bit problematic in 2021. So we designed these devices with a horizontal bar and 3 vertical bars, which go in between the combs. And it's only the vertical bars that are treated with the compound. And we decided to test 2 formats of delivery. One is cardboard and the other one was wood. It was the same thickness as this cardboard, a kind of triply product. And so we had 8 replicants wood, 8 controls in wood, 8 cardboard, 8 controls in cardboard, and 8 times thymol bars positive control. And in British Columbia, we actually had to start early because our mite levels were now too high. So here are the raw data, the number of mites dropped onto the bottom board versus day of experiment. This time we used a higher dose. We used 8 grams per device. And so we decided to treat all the way to day 42, which is what one would normally do. One would normally treat for 6 weeks or roughly 2 brood cycles, 2 almost 3 brood cycles. And then we switched over to Apivar and treated with Apivar as per instructions. So we can see that with our compound, especially in wood, we had a nice mite drop compared to the controls, which are here in red and orange. So we did with the Thymovar. In Alberta, they had a really spectacular drop with our compound and a delayed drop with the Thymol, but otherwise a similar pattern. And if we look at the number of mites per day, we can see that a little bit more clearly, that our compound gave a very nice mite drop at the beginning compared to the control. This was all significantly different. And we did manage to suppress a little bit the mite population explosion, maybe not completely, but we did a pretty good job. This is just the early part blown up a little bit. So here we have the compound in wood, the compound on cardboard, Thymovar, and these are the 2 controls, orange in wood and red in cardboard. And so when we looked then at the percentage of infestation according to alcohol wash, so this is phoretic mites on bees, then we do see that when we compare the control in wood to the treatment in wood, we had a significant decrease at day 42. Similarly, when we can compare the control in cardboard to the treatment in cardboard, we had a significant decrease at 42 days, and Thymol also differed significantly. And then at day 90, we see that, and this is a little bit troublesome, and that when we compare the wood data, there was no significant difference in the number of phoretic bees, mites on bees for the wood treatment. For the cardboard treatment, there was a significant difference, and also for Thymol. And the problem we had was that our fall was like summer. Our colonies in mid-October were full of brood. So we were trying to do this cleanup treatment, which is normally done when the queen has already shut down and when there's decrease in the amount of brood. And we were trying to do this while there was still a full load of brood, and therefore lots of mite reproduction, counteracting our treatment. Right. When we looked at mite infestation in brood, so percentage of cells opened that contained Varroa mites, we also see that at if you look at the control, so we started out equal. This time we did check ahead of time the mites in brood. At day 42, we did have a significant decrease when for the wood devices, and we also had a significant decrease for the cardboard devices and for the thymol devices. However, for thymol, I have to point out that 3 of our colonies died during the treatment. This thymol treatment has to be changed over and repeated after 3 weeks. And in that second phase of treatment, we had some very hot weather, and that killed 3 of our 8 colonies. So these are data just for 5 colonies. So the take-home messages from that, from last year's field trial, was that a dose of 8 grams of our compound lowered the number of mites on bees and in brood over a 6-week treatment period. Thymol lowered the mites the most, but some of the colonies were lost during the treatment, and this happens with thymol. It's one of the side effects. So thymol, I should point out, evaporates faster than our compounds. So the product we use, Thymovar, comes in wafers with 15 grams of thymol on them. And you have to use 15 grams for 3 weeks and another 15 grams for another 3 weeks. So if we compare the amount of material that was used, our compound did a lot better because this was 8 grams for 42 days, whereas this was a total of 30 grams over the same 42 days. And Amitraz performed poorly in our field trial in British Columbia. In Alberta, the data are a little bit crisper, but we are worried that in part it was the weather and the high amount of brood that we had during our cleanup treatment with Amitraz. But we are also starting to monitor for resistance, and we will continue keeping everyone appraised of the results of that monitoring. We have to set up a province-wide monitoring of Amitraz resistance. Right, we said that. Now, just a few days ago, I went out to the yard and had a look at the hives, how they're overwintering. And in fact, we've done this all winter whenever we had an opportunity, a day that was a little bit warmer and allowed us to quickly open the hives, we checked. And so this is the number of surviving colonies, and these are different dates. So October 20th, October 27th, December 7th, January 23rd, and February 17th. And this is very promising because in the control in wood, they've all died. Control in cardboard, there are still 3 of them left at this point in time. The treatment in delivered on wood, there's 4 of them still alive at this time. The treated on cardboard, 7 out of the 8 are still alive at this time. And the 5 thymol ones that did survive our whole experiment are still alive. And so with this, I would like to thank everybody who contributes to this, which is a lot of people. I'm very grateful for funding to the AAFC, that's Agriculture, Agri-Food Canada, the BCHPA, that's the BC Honey Producers Association, Project Apis mellifera Costco, Natural Sciences and Engineering Research Council of Canada, which gave us a lot of funding, the Agri-Tech Innovation Award, Genome BC, which is currently funding a project where we're trying to find out the mode of action of our compound, and my university, Simon Fraser University. All these lovely people who help us, our beekeeper, Caroline Essence, our apiary site owner, Lucy Karnick, our suppliers who give us very gracious discounts, and our collaborators, unfortunately, whose work I couldn't describe today, but we collaborate with Steve Cook at the US Department of Agriculture in Maryland, and Leonard Foster at the University of British Columbia. And thank you very much for your attention. I'm open to questions.
First question right here.
I'm curious about the difference between the wood and the cardboard. Are you using corrugated cardboard or a solid cardboard?
Corrugated, which cause the bees to rip it apart. Yeah. Yeah, and so looking at our data, we, with the cardboard here, you can see lower numbers here. I suspect that they were just as high, but there was so much debris at certain points in time of this experiment on the sticky board, and it was stuck on there that we couldn't remove it and dig in for the mites. So it was hard to count the number of mites accurately. Yeah, that was one disadvantage of the cardboard. But maybe there also was an advantage in that the bees really shredded into tiny particles almost, or fibers. And I don't know what that does, but so far our overwintering data look very, very promising. From an experimental point of view, the wood ones were nicer because we could retrieve them and analyze how much compound was left on them. We couldn't do that with cardboard.
Would also give you more surface area for the fumigant to outgas or fumigate in the hive.
Yeah, we try to make the surface area roughly equal. Of course, cardboard is a little bit lighter and due to the corrugation, in a way more porous, if you will. So it would have, yeah, perhaps a higher total surface area. The wood we actually roughened with a metal brush before applying the compound. So we try to also increase its surface area. I should also point out that in Alberta, they didn't notice that difference so far. Now they can't open their hives yet. So they don't know how well the overwintering has gone. We'll find that out a little bit later in the spring.
Two questions. First, when you look at the 8-gram dosage, how much was left after treatment? I guess you did that on the wood. And then the second question is, this looks really promising. Is there a path to commercialization established, or is that yet to be determined?
Yeah, so for the first question, it's about 12 milligrams that were left. So pretty much the whole thing evaporated. And we're working on and going to publish an analysis method. It turns out that there's a natural compound, possibly from propolis, or wax propolis mixture, that is very similar to our compound. It's not our compound, but it runs very close in the gas chromatography mass spectrometry traces that we use to analyze this. And so I have an analytical chemistry student who's actually optimizing the method and trying to find out what this is and separate it totally from our compound. So with our new analysis method, we know that almost all the compound evaporated in the 42 days, almost the entire 8 grams. Now, as far as patenting goes, yes, my university is the owner of that technology, and we have a commercialization pathway. Yeah.
Thank you.
Are there any other questions? One more.
Was Apivar the only form of delivery you used for amatraz?
Could you repeat that, please? I didn't get the whole question.
Was Apivar the only form of delivery for amatraz that you use?
Yes. Yeah, in Canada, we're not allowed to use anything else.
Another question here.
Have you tested when your compound evaporates, does it rise or lower?
Could you repeat the last part, please? Sorry, didn't understand.
When your compound evaporates, does it rise in the air or does it drop?
Yes, good point. It does in the lab, in lab experiments we've done in jars. The compound does fumigate pretty evenly, but I suspect that in a hive, it'll probably, the vapor, also maybe depending on the temperature, these are things we still need to establish though, that like for other compounds that it might lower just because it would be denser than air. But it is something that we still need to follow up on, exactly how it circulates in the hive.
Other question?
So do you think that the wood that is being used is absorbing the chemical rather than releasing it maybe? And have you tried different types of wood?
Right. No, we used sort of the most economical product we could find at our local, wood store. It's a mahogany supply type product. And I don't think it holds it back because we were only able to extract 12 milligrams from 8 grams. So it's virtually all of it has evaporated. Also, when we treat the wood, we can actually see the coating of our compound on the wood. So it may absorb a little bit, but not too much.
Anything else? Dr. Plettner, looks like that's exhausted the questions here. Thank you so much for being with us today.
Yeah, thank you for the opportunity. And have a successful beekeeping season in Utah.
Thank you. Thank you.
Yeah, thank you.
All right, at this point, we'll invite Doug Hawks, our treasurer, to give the organization financial report. Following Doug, we'll break for lunch. Lunch it was planned to be ready at 12 o'clock. So if Doug is exceptionally eloquent and quick, then you might have a few more minutes to talk. We'll eat afterwards and then we'll regroup, I think at 12:45 is the plan.
You'll have lots of time to talk. My report's really quick. We're not completely resolved on where we are on expenses for this conference. The speaker fees primarily, we're still working on what to do because of all of the changes there. So consider my report a preliminary report at this point, okay? Membership fees, which includes paying for the dinner, we haven't split that out. This year are $4,580. Last year they were $5,260. So we're down $680 from last year on membership fees. I don't know if that's because we've lost interest. Maybe Brian wants to think about that. Our fees have gone down a little bit. The contribution from CKP Insurance last year was $4,000. That he's still working on what his contribution will be this year. It might be that, it might be a little less than that. So that's still an open issue. The conference expenses this year before the speaker fees are $6,680. Last year they were $8,464. And one of the main reasons for the decrease is the speaker travel. We don't have the speaker travel this year, and it was substantial last year. Again, our $6,680 might go up by $900 to $1,000 depending on the speaker fees. So without Mike Browning's contribution And if we have to pay for the speaker fees, we'll be in the hole this year about $3,000. We have a good reserve of cash in the bank to cover that right now. So we're not destitute, let's put it that way, but it's nice to let each year support itself. That's the extent of the report I wanted to provide. I'd certainly welcome any